Hi everyone, we're going to find the solution set for these two rational inequalities. This is part 2. The first one is a not strict inequality. It's not strict because it has an equal sign in it. Okay, the second one is strict because it has to be less than 0. What we're going to do is set it to 0. Okay, so the first one is x minus 2 squared. And I'm going to go ahead and factor the denominator. And we want this to be greater than or equal to 0. And therefore our f of x is just going to be x minus 2 squared over x squared minus 1. And we want this to be positive. Therefore, we've got to find our zeros first. And the zeros is by making the numerator 0. So that's going to be, our zeros are just going to be 2. Remember, with polynomials, that would be a multiplicity of 2 there, but we just have 1 0. Our denominator, when you set that to 0, x is going to be undefined, or f is undefined, at 1 and negative 1. So if you look at a number line, I'll put these in order. We've got the smallest number is negative 1. Our next one is 1. And the next one we have is 2. So we want our intervals to be from negative infinity to negative 1. And then this one here would be negative 1 to 1. This one here would be 1 to 2. And the last one would be 2 to infinity. So those are the intervals we're going to choose. Okay, the intervals actually we have to choose. Again, our equation is f of x equals x minus 2 squared over x squared minus 1. And we want this to be equal to 0 or greater, so positive. So we have negative infinity to negative 1, negative 1 to 1, 1 to 2, and then 2 to infinity. And then we're going to choose numbers in between. So I'm going to choose negative 2. 0 is always good. 1.5. And I'll choose 3. And you plug it in to your equation here. And we're going to get 16 over 3, negative 4, 0.2, and 0.125. So our conclusion is this is a positive number, this is negative, and positive, and positive. We want positive or equal to. So our solution set, since we're going to choose this one, and these two can go together because these are both positive. So our solution set is all x such that x is less than negative 1 or x is greater than 1 because this one includes both positives. All right, the next problem we have was a harder one because we're going to have to simplify this. We have 6x minus 5 is less than 6x. So this is a strict inequality. I'm going to move the 6x over to the left side. So we're looking for negative numbers. to make this easier, finding our undefined, I'm going to multiply both sides by x. So I'm going to get 6x squared minus 5x minus 6 is less than 0, because 0 times x is just 0. I'm going to factor. So when you factor, you get 2x minus 3 times 3x plus 2 all over x. Okay? And all this is supposed to be over x, sorry. Let's see. And that's less than 0. So our zeros are when you set the numerator to 0. And so our zeros are 3/2 and negative 2/3. And of course you set your denominator to 0 to find where f is undefined. And that's going to be x is 0. So it's going to be 0. So we have 3 numbers we have to deal with. And if I put them in order, we're going to have, I'll do a little number line. We have negative 2/3. We have 0. And we have 3/2. All right. Oops. So the intervals we want to choose are negative infinity to negative 2/3. Then this portion is going to be negative 2/3 to 0. Then I'm going to choose 0 to 3/2 for this part. And then I'm going to choose 3/2 to 0. And the number I chose was negative 1, negative 1/2, 1, and 2. All right, and you plug it into your equation. In your equation, you can just plug it into f of x equals 6x minus 5 minus 6 over x. And when you plug in negative 1, you get negative 5. Negative 1/2 would be 4. 1 would be negative 5. And 2 would be back to 4. Okay. We want everything to be negative. So our negatives are here and here. So we want these two intervals. These two were positive, and we don't want the positives. So our solution set is all x such that x is less than negative 2/3, or, and for this one we're going to do x is in between 0 and 3/2. And that's your solution set. Thank you. Have a nice day. Bye-bye.